Hi guys, in this video, let's tackle about the Pythagorean theorem. Now this theorem states that the sum of the squares of the two sides of a right triangle is equal to the square of the hypotenuse. And this can be expressed in an equation as a squared plus b squared equals c squared. So let's recall that in a right triangle, so for example, we have right triangle ABC with the right angle at C. The sides adjacent to the right angle are called the legs. So A and B are the legs of this right triangle, while the side opposite to the right angle is called the hypotenuse. And the hypotenuse is also the longest side in a right triangle. Now, according to this theorem, if we will square A and B, so if we will square these two sides and add them, that would be equal to the square of the longest side or the hypotenuse. So that is why a squared plus b squared equals c squared. So let's take this example for you to understand how this theorem works. Given the right triangle ABC with right angle at C, so let's find the missing part. So the values of b and a are known. So we have b equals 4 and a equals 3. So the unknown part is the hypotenuse, so c. Now, using the Pythagorean theorem, a squared plus b squared equals c squared, we can find the missing part. So since the values of a and b are known, so let's just substitute them to a and b respectively. So we have a is 3 and b is 4. So 3 squared plus 4 squared equals c squared. So 3 squared, that is simply 9, plus 4 squared, that is 16, so equals c squared. So 9 plus 16, that is 25, equals c squared. So let's find the square root of each side to determine the unknown. So square root of 25 equals the square root of c squared. So square root of 25 is simply 5. So square root of c squared, that is simply c. So we find the square root of both sides because we have an exponent here which is 2. So in order to get rid of this exponent, so we will find the square root of this term. So therefore, we have now found the value of the missing part, the c, the hypotenuse. So c is equal to 5. So let's take the second example for you to understand this concept better. So we have here, given the right triangle PQR with right angle at Q, let's find the missing part. So the known sides of this triangle are we have here r equals 8 and q equals 10. So the hypotenuse and one of the legs are known. So the measurement of the hypotenuse and one of the legs are known. So we will be finding the missing part, which is P. So this is one of the legs. So this is the other leg of the given right triangle. So using the Pythagorean theorem, we have r squared plus p squared equals q squared. So r and p, so these are the legs of this given right triangle, and q is the hypotenuse. So r is equal to 8 and p is still unknown, while q is known, so q is equal to 10. So 8 squared plus p squared equals 10 squared. 8 squared, that is simply equal to 64, plus p squared equals 10 squared equals 100. And we will subtract 64 to the both sides in order to get rid of this constant 64 here, so that p squared will remain, or p squared will be left. So we have 64 plus p squared minus 64 equals 100 minus 64. So 64 minus 64, so let's cancel this out. So p squared will remain equals 100 minus 64, that is 36. So let's find the square root of both sides to know, or to get rid of this square in this exponent. So we have square root of p squared equals square root of 36. So square root of p squared, that is simply p, and square root of 36, that is simply 6. So therefore, the unknown side is equal to 6. So p is equal to 6. So that's just it. That is just how the Pythagorean theorem works. So this time, try this one. Given the right triangle XYZ with the right angle at Y, find the missing part when x is unknown. So you will be finding x. Z is equal to 3 square root of 21, and y, which is the hypotenuse, is equal to 15. So find the value of x in this given right triangle. That's all for now. Thank you, and just comment your answer below.